My screen is visible. Okay, so yesterday we were discussing about the roles and understanding of a DevOps engineer. We used to see what kind of we saw actually what role does a DevOps engineer do, what all the evolution process history and evolution process does DevOps follow, and right now what is the actual DevOps. We have seen many areas like SRE platform engineer, infrastructure engineer, operations engineer. We have seen DevOps, CI/CDs, build engineer. So we have seen multiple roles, and we have seen day-to-day activities on a high level. And then we discussed something related to uh, uh, like what exactly the infra engineer. So how this infra and DevOps is going hand in hand. Okay, so earlier it was DevOps, and then later on it started with infra as well. So coming to today's session, we were so it's weekend. I don't want to take much of your time, so it will be a short one since it's a demo. So I'll be talking about SDLC with software development cycle. I hope most of you guys know, but then I want to reiterate and then uh, right from the starting, and then give some glimpses of what exactly does a SDLC mean and how does we fit in there. Okay, so in SDLC, so starting with SDLC, it's SDLC is nothing but software development lifecycle. We have waterfall model. Starting with waterfall model, we do have other models as well, like verification and validation model, and we do have agile method. Agile is the latest model. Agile again, there are in agile also there is an advanced concepts of safe agile and all. But if you see, there is it started with waterfall model. First model is waterfall model. Second one is V model. We do have verification and validation model. Then there is concept called iterative model, and we have other models like spiral model. Not necessary. Then there is I'll be talking in this session. I'll be talking about waterfall model and latest agile methodology. In agile, we'll be talking more on two frameworks. One is Kanban, the other one is Scrum. Okay, so let's begin it. So waterfall model is pretty straight model. What does that mean is earlier when we used to when software came into picture, people wanted to build some softwares, and there should be some criteria to it. Okay, so even before doing that, if you analyze any task, right, not about software, if you go for any other work, uh, see, if you want to travel from Bangalore to Hyderabad, how will you travel? First, you have to understand the route map. If you are driving, first you have to understand the mode of transport, how you want to go. If you want to go by bus, or if you want to go by car, or if you want to go by air. So you have to decide it. So that's a one key important role, and then you have to decide on that. So once you pick the decision of going by car, then you have to decide what car, and you have to check whether everything is ready, and then you have to set the route map. So that is the second one. Third one, you have to start at the source point and see how many checkpoints you have to give, like breaking points for a dinner, tea, or whatever it is, and then you have to again go. You have to calculate the distance, and you have to calculate the times, and you have to calculate. So these are like chunks of pieces. You are dividing your work into chunks of pieces. First you are planning it, what mode you want to travel, and what is the route map, and how many breaks you want to do. So that is what you gather. You plan the things where you understand the requirement. So the requirement is you have to travel from Bangalore to Hyderabad. That is the requirement. So how do you want to go? You have options. So that is where requirements come into picture. One second. Okay. So you want to travel. So that is the requirement. That is the requirement here, and how you want to travel and how you want to go. That is all your planning, and your playing or developing the things on process by process or step by step. That is where you can say consider same things into the software model as well. So now you want to build a software. Let's say Book My Show. So what does a Book My Show do? you have to, it will actually book your tickets. Apart from there are multiple other features, but then we will take one simple feature. So what does it do? It is going to book your movie ticket. So what first we have to take the requirement. So first, to understand how these movie theaters work, first you have to go to the movie theater and find out the uh, process that they are following, and we have to do exactly the same process. And on top of it, we have to see the seats of each movie theater, and then we have to collect the data, and we have to give the shows timings, and then we have to put the price. We have to handle this tax, GST, and internet handling charges. And in Book My Show, we do have options of putting snacks and all, where we can book the snacks in the Book My Show area. So all these are requirements. So this is where requirement gathering come into picture. And once you gather all your requirements, you have to analyze which one is required, which one is not required, or which one is priority, which one is not priority. So first we will group all those things, and then we will do a system design. Once you have all the requirements, you have to design a system. Like you have to understand the tech stack, which tech stack you want to go, Spring Boot, Java, Node.js, or if you want to go for a front end application, which kind of front end application, and then if you want to have a database or message queues, what kind of payment gateways that you want to integrate. So all these things you have to design at system design level, which is here. So once that system design is ready, then you start assigning the tasks to individual teams. Like development team will get all the features where they want to develop. Testing team will get the same requirements where they'll start developing the requirements. So team will get other requirements and they'll start developing the features. Testing team will get the same requirements of the functionality and other stuff where they'll start building the testing stuff. I mean testing related. So everyone will do all their works parallelly. Let's say assume. So in this current model, we are doing it parallelly, but in waterfall model, everything goes in step by step model. First thing is requirement gathering and analysis. Then we have done system design, and then we went into implementation stage where developers start writing the code. Once developers write the code, then testers start testing it. It is not like on daily basis whatever they develop, these guys won't test. Once the entire thing application is developed, then they'll start testing. Means that is a step by step process. Then later on there is this deployment process where you deploy it on production to end user, and then you have to maintain in the sense maintain high availability, the scalings, routings, all these certificate managements, the secure way of hosting the applications, everything you will be managing. So if you see in waterfall model, you are doing it one by one, where when someone is working on one particular step, the other guys will be sitting idle. Like let's say if product design team or product manager is working on the requirement gatherings, the other team will be sitting idle. They are waiting for those requirements to come. Once that is done, the system design team will start working on it. The other people will be sitting idle. So there is lack of coordination, lack of resource, proper utilization of resources, and then there are time gap, lags. There is one such scenario where let's say if you have tested and you have approved it and it went to production, and in production you got some bugs. Now you want to go again from the first step and do one by one and again wait for it to go for production. Till then your production cannot have that bug. So that is where waterfall model lacked. So waterfall model is a step by step approach which is the first SDLC model, and and it is like legacy model which has many drawbacks, but it has uh, uh, its advantages for very small projects. Okay, when you have small project and you don't have any limitations with the time intervals or not a critical application, then you can choose waterfall model. But again, it's a very old model. Okay, so that is where waterfall model failed to achieve what the agile methodology or the next models have been achieved. Okay, directly we will switch to agile model. In agile, we do have multiple frameworks. Like we do have Scrum, Kanban, and there are a couple of other frameworks. I actually forgot. One second. Let me pull out. Oh yeah, this extreme programming. We do have extreme programming. We have lean software development. We do have uh, like what else? We do have feature-driven (FDD), and there is test-driven development. There is dynamic system development, so DSDM. So there are multiple frameworks. But if you have heard, if you are working in IT, or if you have talk to any of your people who are working in IT, they would have been talking about Scrum call or a stand up call, or you have some like update call, whatever you call it as. So all these belongs to one particular model where it is Scrum or it could be Kanban. Only those two, and there is this concept called test driven development or feature driven development that is being used, but again there is a specific use cases for that which we are not going to go in depth about. And there is a safe agile methodology which is very latest. Safe is nothing but scaled agile framework. Okay, scaled agile framework, which is the advanced model of agile. Okay, so let's in our course we'll be talking about Scrum and Kanban. Both are used for project management, but then it has specific use cases. Okay, so let's talk about those use cases. Scrum is particularly used for uh, the iterative purpose of a project. Okay, so when you have a iterative projects, like this, when you are focused on managing the tasks within a team based on some development environment, means like you have an application where you are developing a new feature on daily basis. It's not the same feature that you are developing. You are doing the existing maintenance of the existing applications as well as you are developing a new applications. So in such cases you go with Scrum. So iterative model of developing an application. So in that particular model, we go for we have certain key components like Scrum Master, sprints, product owner, Scrum team. Inside Scrum team, we do have people like developers, the uh, product design team, the architects, lead developer, or manager who manages the entire team. So these are core people of the Scrum. So that Scrum could be very much it very well gels with the development environment where you are developing in a software application on iterative model. Okay, so where it mainly focuses on managing the task within a team on development environment or developing a new applications. That is what Scrum is. So the same Scrum could be used for DevOps as well. Okay, so in DevOps, where do we use Scrum? Okay, so in my previous company, we were using Scrum model only. What does Scrum model do is, uh, so when you have a work environment in DevOps where you are actually developing something like infrastructure development, like you are provisioning the new infrastructure, or you are updating the existing infrastructure, which is an updating, you are iterating the existing infrastructure, or you are creating a new infrastructure. That infrastructure is not from the UI, but it should be doing something to do with the Terraform infrastructure as a code, or Ansible, or configuration management, or developing a new Kubernetes cluster like that. Okay, in such model, or if you are talking about CI/CD, if you are setting up a new pipelines using Jenkins file, Groovy script, or shell script, or you are writing some automations related to your CI/CDs or infrastructures, so that at that point you use Scrum. Means you are developing a project from the scratch, or you are taking the project to the next level, which is in the mid version or somewhere around which has a lot of manual tasks and you want to automate everything. In such use cases, you go with Scrum model in the DevOps world. So when do you go for a Kanban model? So Kanban model is kind of it is used for most of the support projects. Now your project is already well developed and all the applications have been deployed and all are good. Now you have to maintain the project, means you have to do the production support. So in such model, or there is no further development of the new applications. Only you are managing the existing applications. Those applications can be upgraded, but then you don't consider them as a Scrum model. You can consider them as a Kanban, where you won't get many of the new applications. You won't get many new microservices. It's already developed. It's already well settled, and you are just maintaining the existing project. When you are working on the maintenance projects, at that time we will get this Kanban model. What kind of tickets you will get in Kanban? Like you will get the production deployment ticket of the same service which is already there. You are just upgrading the version. So that kind of tickets you will be getting the support tickets. Like if there is any production issue, you will create it, or if there is any access related issues, you will get those tickets from the developers or any other stakeholders where we'll be working in. We'll, okay.
Kalyan, I have a doubt here.
Yeah, yeah. Go ahead. Yeah, go ahead.
You said Scrum model will be useful for a new feature or the existing one, right? So,
Uh,
for the Kanban, you told it is for support one.
mhm.
If it is a existing one also, that can be a support feature only, right?
See,
How it is relatable?
so if your project is well developed, okay, well developed in the sense there is no new upcoming feature coming in. Okay, so it's already there. Like let's say you have a Scrum model and you have a project where you are getting a new requirements. Okay, let's say Book My Show. Since we are talking about Book My Show, first stage of Book My Show is to book a ticket for a movie in a particular region. Second phase of Book My Show is to add comedy shows where you'll be finding some comedy shows in a particular place, and you find a comedian and you stand up comedian and you have, so that is the second step. So the third step is to add some the snack items and all, and you can develop sometimes Book My Show is coming up with a wallet feature. I don't know if it is already there, but let's say if it has a wallet feature, it is coming with a wallet feature, and it has some coupon codes. So all these things, right? It is Book My Show is getting evolved over a period of time. So it is not stopping. Let's say if my Book My Show is stopped at the booking of my tickets for a theater, not going beyond that. So at that time, if I am doing only the upgrades to the existing model of booking tickets only for theaters, then I can take that as into Kanban model because I'm just maintaining the particular project. Maintaining in the sense it comes like patching the existing application. Like if there is any issues or any bugs found out from the customer end or found out in the testing phase, we'll be fixing that. The When you fix those, when you host these applications, you need infrastructure, right? So when you work on the infrastructure, there are a lot of things that gets involved in this, like for example, your machine should be upgraded every now and then. Let's say you have Red Hat machine. That Red Hat machine will be working on like 6.9 or 6.1 micro versions. Now, since there is vulnerability, now Red Hat come up with a 7.1 or 7.2 micro versions. Now you have to upgrade that from 6.9 to 7.1. So you have to understand what is the changes between these two, understand the what are the packages that get upgraded, and see if there is any impact. We have to do impact analysis. If there is any impact that gets created on our application, and then we have to mitigate that impact analysis, and then we have to apply it on the testing machine, and then we have to put it in the production. This entire process comes into Kanban, not Scrum, because here we are not developing anything. We are not creating a new infrastructure. We are just patching the existing infrastructure. Okay, so you are maintaining it. Maintenance in the sense, you purchase your vehicle, could be car or you are not adding multiple new cars. You have one car, your vehicle, and you are just maintaining it by putting petrol, doing timely service, running this insurance, or renewing this insurance, and washing it every now and then. That is all maintaining. You are doing maintenance. You are not buying a new vehicle altogether. When you are buying a new vehicle, then your requirement is more, and since to mitigate your to fulfill your requirements, you are actually purchasing new ones, and you are to purchase a new one, you have to do again all the planning, implementation, budgeting, all those things. So that comes in the Scrum model. Okay, on a high level nutshell, I can give a simple example of that. I hope you understood. If not, let me know. I'll try to put it in a different way.
No, got it. Thank you.
So Kanban is like more of deployment. See, I am working in my current company. We are working on Kanban model. We don't have any sprints as such, like 2 week sprints, 3 week sprints. We don't have. But in Scrum model, we'll be having sprints every two. So 2 weeks time was the ideal time. Earlier in my previous company, we used to have Thursday to alternate Thursday Scrum calls. Sprint call. Okay, every day we'll be having one stand-up call for about 10 to 15 minutes where we discuss the what if we are good with the existing work, or if there is any issues or blockers, or if there is a blocker, other team members will help, or we'll connect with them offline. We'll discuss there for 10 to 15 minutes, not more than that. But sprint call will go for 1 hour where we will discuss for 2 weeks data, like what we have done good, what we have done bad, how do we improve, retrospective kind of thing. Okay, I'll be talking about that, these terminologies in the next session when I will be showing you the dashboards, Jira dashboard or not. But for now, understand the functional at functional level. If you understand, then you can say apply it to the dashboards as well. Scrum calls, Scrum framework will have Scrum calls, sprint meetings. Kanban doesn't have any sprint model itself. It is a daily process. You get daily tickets. You work on it. It is like service management. If you work for IT services, or if you have worked with core infrastructure, on-premises infrastructure, then you'll be getting daily tickets, right? In the service now or any other tool, we'll be getting change managements or service requests. We take that and we work on it, we close it again, we'll take that, we'll work on it, we'll close. So that's a never ending story. Kanban is a never ending story. You don't have sprint calls in that. It is a continuous process. But Scrum will have the iterative model. We are upgrading the features, we are building the features, we are upgrading the resources, you are creating a new resources. These things comes into Scrum model. So Scrum and Kanban, whatever I have talked, it is completely related to DevOps, not to the other models. So Scrum, Kanban in respective DevOps. Scrum with the development is completely different area where that is we as a DevOps engineer should understand that also. I'll be talking about that. It is like simple features where each big feature is multiplied into small tasks or small user stories, and will be assigned to multiple developers. They'll be working on them, and it is also like a sprint model. But Kanban is not like that. In the same way, for DevOps also we do have Scrum, where we will be working on a particular features here in this sense, like either developing a new infrastructure or developing a new CI/CD pipelines, or upgrading the tools from one version to another version, or doing some automations using Python or Bash for these pipelines to make sure that less manual intervention is needed. So in such use cases, we use Scrum model. So Kanban is separate. Kanban is more of a maintenance or support project we will apply. Scrum is more of for development environment, development or iterative model of work. So for that we will use. Okay. So I'll be giving a brief technical things in the next session by using dashboard or not. But for now, that is the high level things. Okay, we do have extended programming extreme programming, lean software development, feature-driven development under agile methodology. But Scrum and Kanban should be good enough. So we covered Jira tool. Okay. Now let's talk about the next topic, which is uh, key principles and goals of DevOps. Okay, we have been talking about uh, DevOps rules, SDLCs, Agile and all. But after knowing all these things, after knowing these many tools, what does a DevOps engineer achieve? Okay, what principles does he follow to achieve these goals? Okay, his in the sense project goals. Okay, so that is where we sit and talk more on DevOps, where by doing all these things, what we will achieve. Okay, so we will achieve communication and collaboration. Okay, so sorry, we have few principles. By following these few principles, we will achieve a few goals. That is this one. Okay, how we will achieve, what we will achieve, I'll be giving in brief. Okay, we will follow collaboration and communication. We do automate things. We have CACDs. Please mute yourself. Okay, so we have CI/CD, we have infrastructure as a code, we have monitoring and feedback, we have shared responsibilities, we have iterative improvements, we have feedback loops. Okay, we do have multiple other principles, but then I'm listing out on top of you. So, what are these principles, and how does these principles help a DevOps engineer to achieve a project goal? Okay, those goals are this one. Okay, let's say communication and collaboration. So, as a DevOps engineer, if you have seen any role, or if you have seen job description, towards the end point or towards the first point or anywhere in the other, I mean, good to have under your under their job descriptions. Good to have, there be one keyword called good to have under that excellent communication skills. They require excellent communication skills or good communication skills. What does that mean? Because every time DevOps engineer will not work alone. Okay, DevOps engineer is a guy who actually collaborates with multiple teams. It could be development team, it could be QA software testing team, it could be database team, or it could be data science team, or whoever it is. We will be collaborate. We are the medium, or we are the channel for all the other stakeholders, because we will maintain the software, we will deploy it, we will give it for the end user. So we are the key stakeholder, key management guys there, and others are all stakeholders. So we will be sitting alone, and other people will be rounding up with us. So in such scenarios, we have to have a good communication. Like we have to listen what they say, and we have to give answers or respond them in a polite way with a clean and crisp answers. Is it? Yes. Want to speak? I think it is by mistake. Okay, so communication is very important for a DevOps engineer to communicate other stakeholders like developers, software team, or end customers. Also, sometimes since we if you work on the operations side, or if you work on the production support side, you'll be directly meeting the end customers also sometimes. So we'll be having a calls with them. At that time, we have to communicate the exact issues that we face, or exact issue that a production is facing, and we have to give a timely response. So for that, communication is very important. So someone who wants to become a DevOps engineer should be very good at communication to give proper responses. Okay, collaboration. Like you, since you collaborate with multiple teams, you will be having a good understanding of all the teams, and you'll be knowing every other team, because everyone every team will have a DevOps team, and or a common DevOps team where they'll be working with, and you will be having that collaboration with all the teams. Whenever there is any issue, at any production issue or something like that, you will directly reach the exact point to come into the rescue, where the issue will get resolved at the earliest. Okay, so that is the main motto. By using this communication and collaboration, we will achieve all these goals. Okay, accelerated software delivery means like if you communicate timely manner, like whenever you see that issue, if you have uh, if you have alerted those particular teams who are responsible, they will also respond back and quickly. You are in a position where you can solve that issues that you are getting in a quick manner if it is not dependent on DevOps team. Again, any issue that comes in our pipelines or in the production or anything, first you have to segregate whether it is DevOps issue or development related issue. So DevOps issue could be like any tools issue, access related issue, or environment issue like staging, production, development, like that servers issue and all. So all these are considered as our issues. If there is any something that is breaking in the code itself while building the code, or if there is any dependency issues, or if there is any anything missing in the modules, code modules, or if there is any missing in the service discoveries of each service in microservice architecture, at that point of time we have to reach out to the developers. So like if there is an issue related to the database, we have to reach out to the database team. So like that we have to collaborate. So with that pace, with the communication and collaboration, that the software delivery process will get faster. So you don't need to wait. You don't need to wait for them to respond. Since you have notified them, they have to notify back, because again, blame will be on them only. So there are we DevOps are like a double-edged sword. So you can break or you can make. So again, we have advantages as disadvantages both as well. As a DevOps engineer, you have to take a lot of blame, or you are prone to take blames because other teams will blame us only. So we, as a DevOps engineer, should be always alert to notify the other teams if the issue is their side. Okay, that we have to follow. So that communication and collaboration is very must. So with that, we will be achieving software delivery, reliable and stable systems, enhanced collaboration and efficiency, continuous improvement. So when you communicate only, then only you get those understanding of what they are expecting and how we have to deliver. Okay. So next is automation. Automation is like very less manual intervention should be there in our entire pipelines or in any infrastructure related activities. So there should be less manual intervention, which means more automation. So by using that automation principles, we will achieve when you have less manual intervention, there is less resources required or less issues faced. So when you have human beings like put their hands, then only the entire pipeline things breaks. So as long as automation works with the latest modules and latest versions, it should be always good. So automation helps to achieve all these goals again. Okay, so CI/CD, we have already discussed what continuous integration and continuous delivery do. Those are pipelines that is going to boost the build and release process. We will have this build and release process faster, and with all these multi-branch pipelines, pipeline scripts, and these workflow libraries, branching strategies. With all these things, our pipeline looks will be very smart, and you'll have a clean and crisp outputs out there. Yeah, and it is very reliable outputs that we can see from those CI/CDs. Okay, we have to build such kind of robustness in our CI/CD such that it is always reliable and stable all the time. Okay, the output that our CI/CD give, that is like you can trust those things blindly. Means you can deploy it into the staging or production, something like that. You are not faking any CI/CDs. See, you can bypass few steps where you can make your job work, but that is not the case. You have to always ensure that each and every stages that we have written inside our pipeline should be passed. Then only the entire job is passed or build is passed. Then only it is moved to staging or production. So like that, CI/CD will impact. So infrastructure is one key thing that we have discussed yesterday. So that is where another one big principle where DevOps engineers should handle infrastructure as well. That too as a code, infrastructure as a code. It could be Terraform, it could could be Pulumi, it could be AWS CloudFormation. But then DevOps engineer should maintain the infrastructure as well to achieve what he wants to achieve on the infra side, which means like so when you provision infrastructure only, then only developers can deploy their applications. So they write the code, we will build the code, deploy it on the VM machines or Docker or Kubernetes. So that is where the infrastructure as a code comes into picture, where we write the Terraform code to create the infrastructure, which will be available for the developers to host their applications. So monitoring and feedback. Once you do that infrastructure development and all, so we have to monitor, right? We have to monitor the pipelines. We have to monitor the. So there is multiple things in the monitoring. So security monitoring. We have application monitoring. We have network monitoring. We have infrastructure monitoring, like compute and resource related monitoring. So we'll be monitoring all those things, and we have a feedback system where if something breaks, we have to see what is breaking, and once we have fixed it, we have to create a root cause analysis, and we have to fix that permanently and take that as a feedback, and in future try to avoid those issues. That is what a feedback mechanism does. So feedback mechanism will always help you to improve your project, improve your pipelines, improve your automations. Okay, so these are main principles and goals. There are many. You can talk about these principles and goals entire day, but I have listed few which I feel that these are important. Okay, so that's about principles and goals. There is an overview of DevOps where uh, I'll just give a small brief, then I will leave it for 5 minutes for questions to be asked, and then we'll wind up the session. So, overview of DevOps is like we do have DevOps, which is development and operations, which involves multiple things. Okay, so I'll give some glimpses of each what each tool do, and in our ecosystem what we are using. I've already given in the course overview, but if you have missed it, this is the right point where you can also listen once again. When you see, the reason why I'm repeating couple of sentences is when you keep on listening to those terminologies, at least you will remember those terminologies when you go for an interview or when you sit and try to practice it. Okay, so that is why I'll keep on because these terminology will be very new for you guys. So when you talk about it or when you listen more about those words, then you will get those things registered in your mind. Then you will talk about it. At least you will remember when you go for an interview or when you try to practice. Okay, I have not, this is not a new thing. I have already listened to it, or I have heard this word somewhere. So that is how you started. You start analyzing the things. Okay. So overview of DevOps, like I said, Zira is a project management tool. Okay. So Confluence is a tool where you do documentation. So both these two are Atlassian products. Atlassian product. You can call it as Atlassian products. Okay. So these two are project management related tools. This is completely project management tool. This is documentation tool, where we document all the steps related to our project, the hierarchies, the point of contacts, the managers, service owners, everything will be listed over here. The entire project model, setup, everything. Okay, so sorry, Git is again a tool where I've already discussed. It is to store the code. In our course, we'll be covering that. Okay, we do have DCOS. Again, this is a deployment tool. I don't think this is required. We go for Docker, where we create an application image, and then we will deploy it. So in the code phase, we use these three. In the code building phase, we use these three for code building. So we develop the code, push it here, and in Jira we will get the requirements, and in Confluence we will be writing something related to the application or application architecture related, or it has some dependencies, or if there is any standard procedure documents that we need to follow, we'll be having this. This is from the code stage. So there is build stage, I think we have to go this way, not this way. So there is build stage where once the code is developed, we have to build the code to create an artifact, because plain code, if you give plain code, it doesn't work. So we have to go with code building where you will get a properly built code. So in our case, if we go for Java, we have Maven, we have Ant, we have Gradle. So here these particular options is Maven. I don't know what SBT is. Exactly SBT or SBT. Let me check it out. Software build tool. The Scala build tool. It seems Scala build tool. I don't know what that is. I know Scala, but okay, Scala also had something. Okay, it's okay. No, not a problem. We have Ant, Gradle, MS Build, all those other build tools where you can follow. If it is a .NET application, it is MS Build. If you are going with Java Spring Boot application, you can go for Maven, Ant, or Gradle. Okay, in our use case, we'll go with Maven, and there is this phase in the DevOps. So this is continuous integration and continuous delivery phase till here. Okay, till whatever we see, code, build, test, release. This is on CI/CD. This is on CI. This is on CD. Or you can call, see, there is multiple things: continuous integration, continuous delivery, and there is continuous deployment. So code, build, test, release comes under CI/CD, which is continuous integration and continuous delivery, not deployment, delivery. So the other phase is called continuous delivery, feedback, or monitoring, or whatever you call it as. We'll go one by one. Okay, in the testing phase, we'll be doing some testings. Like if it is unit test case, if it is Java application, you have JUnit, like which I was telling yesterday. And if it is functional level testing, we have Selenium. Okay, in the test phase, we will do that. In the release phase, once that is both done, we have a release option where we will be releasing the once this testing and all looks fine, and job is success, then we will release that software. If it is dev branch, it could be snapshot. If it is release branch, then it is a release artifact. So we will store that artifact into one artifact repository tool. So we have discussed artifact repository tool yesterday, I think day before yesterday. It is Nexus, or it could be JFrog, or it could be any other tool. Okay, so in our use case, we are using Nexus. So we have CodeShip. I don't know what CodeShip is, but then we can take Nexus as an example. And during these entire phases, right, we have to integrate all these tools with one CI/CD tool, which is Jenkins. So Jenkins is the heart of entire continuous integration, continuous delivery, deployment, testing. Name anything, monitoring also. If you say so, monitoring also can be done through Jenkins by doing some scripts or invoking some agents and all. Okay, so this is the heart of Jenkins, and in during the release process, it is mentioned as under the release process. But then this Jenkins will integrate all these tools, including Jira. Okay, so you can integrate Jenkins with all the tools, and that's how Jenkins plays a crucial role. Even if this side of the tools will be integrated with Jenkins. Okay, so till here it is continuous integration and continuous delivery. Let's talk about continuous deployment. Continuous delivery is nothing but if you are delivering a software as a package to store it somewhere, that is what we call it as delivery. You are not deploying it into the server. You are just putting the application package in artifact repository tool, where you are storing all the artifacts. So in delivery process, we do store artifacts in the artifact repository tool. In the deployment, in the continuous deployment phase, we deploy the artifact by taking from artifact repository tool and put it in the production servers or staging servers. You are actually deploying. Deploying here is nothing but server related. If you are doing it delivery process, you are putting it in the storage or from third party servers to store it for future references or dependency management, like I said in the previous classes. Okay, continuous delivery deals with software delivery process, means software release process. You are releasing a software into artifact repository tool. Continuous deployment is continuous deployment involves in deploying a software on the servers, not on the artifact repository, but on the plain servers where you host your application, and the end users will start accessing that. Like Facebook, when you deploy that Facebook on the servers, then you start accessing it. But if you have a package of your software application, then you can store it in any of the Nexus or any of the artifact tools. Okay, so that is the key difference. Continuous delivery is different, continuous deployment is different. Next time I'll be showing some animation kind of diagram, and I'll be explaining in detail by taking one more application as an example. Okay, so that is what continuous deployment is. Deployment could be done on Docker, AWS, I don't know what DCOS is, but you can use other tools like Urban Code Deploy, UCD. And all. Okay, then there is this operate where we do some configuration management or do maintenance. It could be done through Chef, Ansible, or Kubernetes. Kubernetes doesn't come, but ideally, I don't know why this image is keeping this. Maybe I will change the image next time if I'll be uploading the proper things in the session in our platform. But then operations are nothing but uh, patching the existing servers or updating the existing servers or infrastructure by using any configuration management tool like Chef, Ansible, or if it is a Kubernetes cluster, that also you can actually patch it, but there is a different story to it. Okay, then after doing all these things, you have to monitor, right? You have to do monitoring and stuff. How do you monitor it? You monitor it through multiple tools, like you have Nagios, you have Splunk, Datadog, Prometheus, Grafana, Zabbix, ELK Stack, where you monitor infrastructure, log monitoring, the application monitoring, network monitoring, incoming requests, outgoing responses. We have to respond. We have to track everything. So with proper monitoring system, we can do that. We can achieve that. And this is one. These are few tools that can be considered for monitoring. So Splunk is major use for application logs, application monitoring. So I've seen Nagios is predominantly tracks the infrastructure related things. Okay, Datadog also it's more of infrastructure related thing only. Uh, but then it is not constrained to only infra. Those guys might have been expanded their features to monitor application and the other stuff also. Okay, so that is about overview. Again, I'll be giving a proper animation and the tools that we cover in our scenarios with proper diagram. Proper animation diagram, and I'll be explaining the feedback system, notification system. If a job fails, how do we get a notification through Slack, email, and stuff. Okay, so that is about overview of DevOps. Let me know if you have any questions. I'm happy to answer. I'll leave it to the team. Stop presenting. So if you have any questions, do let me know.
All these tools will be covered in course as well, Kalyan.
Not all. I
Or
have
only
already no. I have already given in this course content. Not all. One tool for each of these process. Source code management tool we are using Git, CI/CD tool Jenkins, SonarQube for code quality checks, Nexus for artifact storage, AWS for cloud, Terraform for code infrastructure as a code, Ansible for configuration management, container orchestration, Kubernetes, Docker for containerizing applications, Python and Bash for automation related scenarios, and then Prometheus and Grafana for monitoring, ELK stack for log monitoring. Okay, so these are the tools. If I missed Maven, Maven is a build tool SonarCube is a static code analysis tool. So on a high level, these are the things that we are covering, not everything. You don't need to learn everything under the roof. One any few tools, if you can master it, if you are very good at any one thing, DevOps or any little bit of CI/CD, DevOps strong and little bit of SRE can also work. Very strong in SRE and little bit of DevOps, that also work. If you are too strong in both the things, then you are the top pool of DevOps guys. So very
Okay.
less.
Example for deployment, you told DCOS, Docker,
No, no,
AWS.
no. That
So
DCOS,
you are
DCOS is. I don't know what DCOS is. I don't know how. Let me check what DCOS is. Deployment tool, I don't know. It could be something that is very old too. Um, Deploy
okay. I'm not
DCOS.
bothering about that. So you told Docker and AWS.
Uh,
So for both, the functionality will be the same.
no, AWS is a cloud. It holds entire infrastructure. Docker is a container management tool, or you containerize your applications there. Okay, so to understand that better, we have to go into the tool and then discuss. So both are two different things. You can deploy your applications on Docker, means like Docker platform, or you can also deploy your applications on AWS infrastructure. Like it could be virtual machines, it could be Kubernetes cluster, or it could be ECS container services, or it could be any third-party tool. There are third party like Lambda, not third party like serverless things. So you have a lot of things there, but again, we can discuss that in upcoming classes.
Okay, okay.
So we deal. So in our course we cover both Docker and AWS. I'll be showing how to containerize application, and I'll be showing how to deploy those containerized applications on EKS cluster and normal applications on EC2 machines using Ansible.
Okay, Kalyan, fine, thanks.
Any other questions anyone have? Three, two, one. Have a nice weekend, guys. We'll see you on Monday. I'll be updating the classes, and if there is any new links, I'll be posting in the groups. Thanks all.